Warning, the video you're about to watch contains mathematics at the level of differential calculus, also known as Calc 1. All material has an assumed prerequisite of pre-calculus and a full semester course in trigonometry. A thorough review of prerequisite topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
This is one of my favorites. You have a water trough. It's 10 meters long, and a cross section has the shape of an isosceles trapezoid that is 30 centimeters wide at the bottom, 80 centimeters wide at the top, has a height of 50 centimeters. So that's the physical dimensions. You can actually draw that. That's actually not too terrible to draw, so I think I will. Okay, I have to say, this is the best trough I've ever drawn, and it's because I was using a ruler. So anyhow, so that is an isosceles trapezoid. Just means that the sides, it has that symmetry just like an isosceles triangle does. Let's see, the top, the water trough is 10 feet long, or 10 meters long. So this is 10 meters that goes back. It's a three-dimensional drawing. And one thing you need to note whenever you're dealing with any type of physical problem, you want all your units to be the same. So if that depth is 10 meters, you need to transform everything into meters. It's 30 centimeters wide at the bottom, so therefore it is 0.3 meters at the bottom. The top, from here over, actually, you know what? I should not use black there. I'll use green. The top, from here all the way to there, is 80 centimeters, which is 0.8 meters. And let's see, the height is 50 centimeters, so this is 0.5 meters tall. That's what that dashed line is the height. So now we're going to fill it up with some water. And it's being filled with water at a rate of 0.2 cubic meters per minute. And that's exactly why I decided to do all my units in terms of meters, because I didn't want to transform this cubic meter per minute into centimeters. That's just no fun. So sorry, I'm just changing all the colors because I have an issue with different colors. Anyway, how fast is the water level rising when it is 30 centimeters deep? Or in other words, 0.3 meters deep. All right, so let's draw some water in there too, just because we can, and I feel very happy with my drawing right now. I guess that looks okay. Anyhow, we want to know how quickly is the water level rising when the height of the water, and let me go ahead and just say the height of the water here, is 0.3 meters. Now it's not 0.3 meters forever, so I'm not going to substitute that into any formula initially, but it is 0.3 meters when we stop time to measure how quickly the volume is changing, or how quickly the height is changing. So let's see, I've read the problem, and by default, I just always like to draw it. So I've already drawn it. I understand, what's going on. Although I may be intimidated by the problem as far as setting things up, I still understand what's going on. Now, the next part is critical, labeling. So we're going to label things here. And let's see, to label things, it's probably easier to label what we want. So I'm going to state what we want first. So let's see, what do we want? How fast is the water level rising when the water is 0.3 meters deep? Okay, so I'm going to call the depth of the water, I don't want to use D again. Can I just use H? I'll use H. That's the height of the water. Okay. So I want dH dt when H itself is 0.3 meters. Okay, that's what I want. Let's see what we were given. And usually when you're dealing with the givens, the geometry is not really what you're worried about. It's, is there some type of rate you were given? And we were. If the trough is being filled with water at the rate of 0.2 cubic meters per minute. Well, that's a rate of change of volume. Cubic meters is a volume. So that's the rate of change of volume with respect to time. So we've been given the change of volume with respect to time. It's always, because the hose pours at the same rate, 0.2. And if you want to write cubic meters per minute, you can. It's not illegal. You could totally do that. Those are the only two things that we were really truthfully given. So we need to create a master equation that relates volume and the height of the water. Let me go here, volume and height of the water. We need some equation that gives me the volume in terms of H, essentially. And that shouldn't be too bad. Now, I want to tell you that it's symmetric. So as long as I find the volume of one triangular piece here, then I have the volume of the other triangular piece. So, and I say triangular, but it's actually not a triangle. It's a triangle prism. So anyhow, so the easiest part of the volume, let's start creating the master equation right now. So label done. Now we go for the master equation. And the master equation means we'd like to create something with volume and H and relate them to each other. So let's see, what is a good formula for the volume? I think I'm going to need extra room here. Well, let's go ahead and talk about pieces. There are three pieces to this volume of water. There's this center piece right here. And the center piece is actually a big blocky chunk. I'm trying to zoom out, but it's not working for me. It's a big blocky chunk. It's just this, right? That's the center. And that's an easy volume. It's just 0.3 is the width, and that never changes. The height is H, and then the depth is 10 meters. Again, that's this block. It's 0.3. It's got a height of H and a depth of 10. I hope that makes sense. And now we have two of these edge pieces, and the edge pieces look like this. Let me zoom out a little bit. This is one edge piece. Not bad for freehanding this stuff, by the way. And that is a height of H again. This is a depth of 10. But remember, this is a triangular front end on that thing. And so we're going to need to find out, what is this piece right here? I don't know what that distance across is. Because remember, the area of a triangle is 1/2 base times height. So I know that the front loaded area, this area right here, is 1/2 x times h. Let me write that in. 1/2 x times h times the depth of that slice. Again, 1/2 x times h would be the front area here. And then times 10 would give me the entire volume of that slice. So I pull that out of the trough. And because we have two of those, I have a 2 in front of that, because we have both the right hand and the left hand slices that we're going to be pulling out of that. That is our volume formula. Now, obviously, there's way too much stuff going on here because we have h's and x's, and we don't want h's and x's. We only want h, right? We want v is equal to some function of h. So I'm going to first clean this up. This is 3h plus 10hx. At least we got that far. Now, how the heck do you find out what that x is? This is where your Calc 2 is going to be born from, this idea that we're about to talk about. So Calc 2, you're going to use this idea quite a bit. You have this side of your trough, and remember, the top of the trough, they gave us as 0.8 meters for a reason. We know that the bottom is 0.3, so from here to here is 0.3 meters, that is. That means we still got a 1/2 meter to split among the other two sides. So this must be 1/4 of a meter, and this must be 1/4 of a meter. And this will give me 0.25 here. It's a height of 0.5, and we have water in here, which I'll go ahead and say that it's up to this point. We have water up to that point, and because I feel very artistic, I'm just spend a moment to draw my water in here. I'm not super artistic, but I'm somewhat not at all artistic, honestly. But we're saying that the height of that water is going to be h. That's what this distance is. And we called this x. That's just from this picture. Now you can use what are called similar triangles. 0.25 is to x as 0.5 is to h. And then I can solve this for x. So I'll take the reciprocal of both sides and then multiply both sides by 0.25 to find out what x is. X is equal to h times 0.25 over 0.5. That's 1/2. And now we'll go ahead and substitute that in. So there is a little extra work with this master equation, but once you get it, this is 3h plus 10h times 1/2 h, or in other words, our volume is equal to 3h plus 5h squared. I'll box that up. That's the hardest master equation that we've had. But it goes to show that a good drawing helps out quite a bit, and similar triangles, which are going to exist in Calc 2, you got to get to know those, or remember those, actually. You already know them, you just have to remember them, that's all. Now let's do the rate equation. Thought you were done, right? Let's take the derivative of both sides of this with respect to time. So dv dt is equal to 3 dh dt plus 10h dh dt. Now that we have the rate equation, we're going to do the sub and solve. So what are we substituting in? We're going to sub in h equals 0.3 and dv dt is equal to 0.2. And let's see what we get. We get 0.2 is equal to 3 dh dt plus 10 times h, which is going to be 3 dh dt. So we get 6 of those dh dt's. I'm going to divide both sides by 6. That's 1/30. So at that time, this implies when h is equal to 0.3 or 30 centimeters, I'll just say that. When h is equal to 30 centimeters, the volume, or the height, sorry, is changing at a rate of 1/30 of a meter per minute. There you go. That's a pretty robust problem. One of my favorites, though. I really love this problem. I think it's a fun problem. It's actually not bad. By the way, I did the rate, I did the sub and solve, and I stated the solution. Check. Okay. I really dig these. I think they're great for exams, honestly. So you can look in a textbook or look online for other types of troughs, other shapes you can have. It has to be a standard shape, something you can actually find volumes of. It can't be a weird oddball shape.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.